In this video, we prove the inductive step in our induction proof that that statement is true for all n. Right, so remember what we're trying to prove here is the if-then statement. If P of k, then P of k plus 1. That's what we're trying to do. We're trying to prove that this statement is correct. Now remember, how do you prove an if-then statement? You assume this and show this, right? So this is our assumption here. We get to assume this is true. And we want to show this statement here. All right. So we're going to give a left-hand side equals right-hand side proof. This is our left-hand side. This is our right-hand side. All right, now it'll help us in the proof to when we're working through the proof, we're going to be looking for this right-hand side to crop up. Now this right-hand side is written in kind of a weird form. We got this k plus 1 plus 1. K plus 1 plus 1 is just k plus 2. So let's write this as k plus 1, k plus 2 over 2. And we'll look for that piece cropping up there. Okay, so now starting with the proof, let's start with the left-hand side. This is 1 plus 2, and I could say plus 3, but for the sake of saving space, I'm just going to go to k plus 1. All right. Now the thing I want you to see here is that, look, in our assumption tells us something about adding up to k. And notice that this is exactly what we have right there. So notice that the blue box and in the two blue boxes, these are exactly the same, right? They're the same thing. And so our assumption tells us that the blue box adding up to k is equal to k times k plus 1 over 2. We want to justify this step. This is the inductive assumption. Or you can just write P of k. I'm perfectly fine with you writing P of k because that is the inductive assumption. The inductive assumption is P of k. All right, so writing P of k there says that you're using the inductive assumption to do that. And then, so this is the power of induction right here, so being able to put this P of k here. And then after that, it's just algebra, getting things to look the way we want them to look. Okay, so and how do we know where we want to get to? It's the right-hand side. Okay, so let's see. What we'll do is get a common denominator. Let's see. Let's see, putting those together. Okay, so first, let's see, this step right here, I just get a common denominator of 2. Then here I'm putting them all over the same denominator, which is correct algebra. Now I'll distribute the k through and get k squared plus k plus 2k plus 2 all over 2. And now notice that k plus 2k, right, I can combine like terms and turn that into 3k. So that's 3k there. K squared plus 3k. That was k plus 2k is 3k. And now factoring, notice that I do in fact get k plus 1, k plus 2 all over 2, which from our work above, right, we can see that that's actually equal to the right-hand side.